In this video, we're continuing on with our SHA 256 GoLang implementation, and this is the compression step. So just a quick review, we did input and pre-processing last video, input, message block construction, message schedule construction, and then in this video, we're looking at compression. So we're looking at the initialization of working variables, the computation of temporary words and mutation of working variables, and then we're looking at integrating and computing, so computing and integrating the computed variables and the mutated working variables with the initial values. So just pulling up the NIST specification again, now we're looking at this compression step. So first thing we're doing is initializing the 8 working variables, A to H, and then the next thing we're doing is we're looping through all of the words in our message schedule, our passive message schedule. We're constructing 2 temporary words using some more logical functions. And then we are mutating our registers. So G is going to H, F is going to G, E is going to F, D is being added with temporary word 1, and then going to E, C is going to D, B is going to C, A is going to B, and then T1 and T2 are being added together and going to A. And then once that mutation has been done, we're going to compute the intermediate hash values, but in our case, since we're using an input or testing input of ABC, it's just going to be done once, but obviously you can do this, this will happen as many times as needed. And then once those variables are computed, they are passed back to the main function, and either they're passed back into compression again in the next round with the next message schedule, or they are concatenated and spit out as the final value. So jumping back into our main file here with our main function, we'll get down into our getHash function. So last video we talked about the pre-processing steps. We had our message blocks built, and then, oh, we don't want to do that. And then we did our message schedules. So in this step, we need to, our compression step, first we need to initialize our values, and then we need to compress our message schedule. So let's go ahead and jump to definition on our compression function here. And here we go. So we have our message schedule being passed in, and our chaining values, or our initial values, are our chaining values. So what's happening here with this loop, we got our hash values, having those initial values passed to them, and then before the loop, because we want them to be the initial values, then that's being passed along with the message schedule to this compression function. And once that is done, we are initializing our working variables. So we're taking those initial values and we're using them to initialize our registers A to H. And once those are initialized, we're jumping into our loop here to calculate our temporary words and then mutate our registers. So this temp word 1, we have H from our initial register being added to the result of the big sigma 1 logical function being passed the register E. So we can just do a quick jump to definition to have a look at that. So with big sigma 1, we're doing a rotate right 6, XORed with a rotate right 11, XORed with a rotate right 25. And then that result is being added to the choice logical function. And this one's a little bit different. We're having 3 values passed in E, F, and G. Just have a look at that one really quick. And so what's happening with this one is we're doing an if X, then Y, otherwise Z. And you can have a look and see how that's working here. So we're having X ANDed with Y, and then we're taking the XOR of that and we're doing the NOT of X ANDed with Z. And so we take the result of that and we add constant 1. So remember we talked about what the constants were. It's the fractional portion of the cube root of the first 64 prime numbers. And we have them listed up here because they were specified by NIST. And then we're adding that to our first message schedule value. And that's how we get temp word 1. Temp word 2 is pretty similar. So first thing we're doing is doing big sigma 0 function, logical function on the A value. Big sigma 0, we're doing a rotate 2, XORing with a rotate 13, rotate right, I should say, XORing with a rotate right 22. We're returning that value, and then we're adding it to a majority logical function, A, B, and C being passed here. And so majority is right here. So X ended with Y, X or X ended with Z, X or Y ended with Z. And then once we have that, we have our two temporary words, and we can get into the mutation. So G is going to H, F is going to G, E is going to F, and then we're adding D with temp word 1, and that's going to E. C is going to D, B is going to C, A is going to B, and then we're adding the two temporary words here and passing that to A. And so we work through all 64 of our message schedule words in this way, in this loop. And then once we've done that, we have all our mutated registers have been very mutated through all of that looping. And then we calculate our chaining variables here. So we have our hash values byte array, and we're appending A plus chaining values 0. And so chaining values is our initial value that was passed in. So after we do all of those mutations, we take our mutated value and we add it to our initial value here. And we're doing that for all of these, and we're just appending them to this byte array until we have all of our chaining variables added to the array. And then once that's done, we return that value. We return that value to our main function here, so hash values. And then again, like we talked about, if there's another message block that needs to be turned into a message schedule and passed and compressed, then we would loop back through and do that. But since we're using a test value of ABC, we don't have to worry about that. We only have one message block to deal with. So what happens from here is we get our final value, and we'll cover that in the next video.